Okay, so here are the notes for section 1.5, so you can pause whenever you need to in order to be able to stay caught up. So essential question, how do you find the complement and supplement of an angle? All right, so our first main idea is going to be special angle pairs. And the first one is going to be complementary angles. And complementary angles are two angles that add up to 90 degrees. It has to be two angles, can't just be one angle because then that would just be a right angle. Or it can be three angles that add up to 90. It has to be two angles that add up to 90 degrees. So then if I were to draw an example here, let's say that's 30 degrees. And then we've got angle B, 60 degrees. Then we would be able to say that angle A and angle B are complementary angles because when you add them up, they equal 90 degrees. So they can be not touching each other. So it can be two angles that add up to 90 and they're not touching each other. Or another example is if you had this picture. Let's just say I had 1 and 2 in here, and you have the right angle box. So then you would know that angle 1 and angle 2 will add up to equal 90 degrees. We just don't know exactly what they are, which is okay. It doesn't matter. We would still be able to say that angle 1 and angle 2 are complementary because by angle addition postulate, you would see when you add those two, they have to equal that 90 degrees. So those two different types, two different ways you can draw complementary angles. Then we also have supplementary angles. And supplementary angles are two angles that add up to 180 degrees. Again, it has to be two angles, can't just be one angle because then that'd be a straight angle. It can't be three angles that add up to 180. Supplementary angles are specifically just two angles that add up to 180 degrees. So again, if I had another example here, I could have a picture like this. So angle 1 and 2, since this is a straight angle, so that from there to there is 180 degrees, so angle 1 and 2 would have to be supplementary because when you add them, they equal that 180 degrees. So they can be touching each other, adjacent to each other, or you could have a picture like I had before where they're just two separate angles. So let's say I had angle C, and then you had angle D over here, and let's say this is 120 degrees, and this is 60 degrees. So angle C and angle D are supplementary angles because they add up to 180, but they don't necessarily have to touch. So there's, again, they could be adjacent or not adjacent. Okay. Okay. And then we also have adjacent angles. And adjacent angles have the three following characteristics, and they have to have all three characteristics. They have to share a vertex, and we talked about what vertex was. They have to share a side, and they can have no common interior points, which basically means they can't overlap. So one angle can't be inside the other angle. So if you look back up here in my example, like this, for instance, this is an adjacent angle. Angles 1 and 2 are adjacent angles because they share the same vertex right here. They share this side because the sides for angle 1 are here and the sides for angle 2 are here. So they share this side. And they don't overlap each other, meaning angle 1 has its own space, all of this space, and angle 2 has its own space, all of that space. So angle 2 is not inside angle 1 or vice versa, okay? Up here, these angle 1 and angle 2 here are also adjacent. They share this vertex, they share this side, and again, they have their own space. They don't overlap, okay? All right. Next vocabulary term is a linear pair. And a linear pair are two adjacent angles whose non-common sides are opposite rays. So if I were to draw a picture of linear pair, because the definition isn't super helpful, here's an example of a linear pair, angle 1 and angle 2. So these are adjacent angles because they share a vertex, they share a side, and they don't overlap each other. And their non-common sides, which would be this side and this side right here, these are the sides they don't share because they share this side. are opposite rays, which means they form a straight line. So that's the linear part. So you've got linear pair means you've got a line and then you've got two angles here. So then angle 1 and angle 2 are a linear pair. You do need to know the definition, but it's hard from the definition if you don't understand what all these things are on how to draw it. So two adjacent angles, they share a vertex, they share a side, and they don't overlap. And they're non-common sides, so the two sides they don't share, which is this side and this side, have to be opposite rays. And we learned in section 1.1, opposite rays make a straight line. Okay, so that's a linear pair. Then we have vertical angles. So vertical angles are two angles whose sides form two pairs of opposite rays. So again, definition's not super helpful. So here's an example. So if I were to draw two intersecting lines and label these angles 1, 2, 3, and 4, then angle 1 and angle 3 are vertical angles. And there's actually another pair, angle 4 and angle 2 are also vertical angles. So when you have two intersecting lines like this, you have two sets of vertical angles. So two angles, so if I'm looking at angle 1 and 3, whose sides form two pairs of opposite rays, so this side of angle 1 and this side of angle 3, those are opposite rays because they form a straight line. And this side of angle 1 and this side of angle 3, those form a straight line, so those are opposite rays. So that's what the definition is telling us. Okay? All right, so in the left-hand margin of your notes, not on that left-hand page that's empty, but actually in the left-hand margin of the notes that you've taken so far, I want you to write a study question that reflects those notes. It could be a level 1, level 2, level 3, whatever you want to make it, but pause here and write yourself a study question that reflects that those 5 vocabulary. All right, so now let's glue in, and you're actually going to go ahead and glue in all of the examples, so you can go ahead, we're not going to take any more notes, like vocabulary terms or anything. Now we're just going to practice, so all of those examples, you can glue in all 5 of them, are going to help us practice with those different vocabulary terms and such. All right, so let's look at it. Decide whether the numbered angles represent adjacent angles or not. If not, explain why. So you have to say which of the 3 things does it violate. Okay. Okay, so part A, angle 1 is this angle here, and angle 2 is this angle here. So we go through the list. So they share a vertex. They share this side right here, and they don't overlap. Angle 1 is not inside angle 2. They each have their own space. So then this answer is yes. And we don't have to say why because it has to be all 3 of those characteristics that it says are good. Okay, let's look at part B. Now I want you to understand, because notice they put a number 4 and a number 3 inside this angle. What this arc is showing you here is that angle 3 is inside this angle, so this is angle 3, and angle 4 is actually from here to here. So angle 4 is this whole big angle. Okay, so that's what this picture is showing you. So when you have two numbers like that in the same angle, but you see this arc, that means angle 4 is this big angle from here to here, and angle 3 is this one. Okay, so they share a vertex. They do share a side, only they share this side, because angle 3 is this and angle 4 is the whole thing. So this is the side they share, but they overlap because angle 3 is inside angle 4. So then this is not because they overlap, which is that they can't share common interior points. So if I pick a point right here, that point is inside angle 4 and it's inside angle 3, and that can't happen. Okay, so that's the whole overlapping piece. All right, and then part C, 5 is this angle, 6 is this angle. Right away it violates. They don't share a vertex. Angle 5's vertex is here and angle 6's vertex is here, so we can't do that. So you can say no, and once it violates one of them, you're done. So don't share a vertex. You could also say it's because they don't share a side or they overlap, because they do kind of share a partial side, but not a whole side. So it violates all three. Okay. All right, example 2. Find the complement and supplement of each. So complement comes from complementary angles, and that's when you're just talking about one of the angles, you say complement. And supplement comes from supplementary angles. That supplement is just when you're talking about one of the angles. So they're giving us an angle and they want us to find the complement and supplement angle that goes with each. Okay, so part A, angle A is 33 degrees. Well, what do we know about complementary angles? Two angles that add up to what? 90. And so for the complement, we'll just use capital C so you don't have to write out the words every time. So then we would do 90 minus 33 in order to get the complementary angle, which is 57 degrees. So the complement of angle A has to measure 57 degrees. And then the supplement, excuse me, remember that comes from supplementary, which are two angles that add up to 180. So 180 minus 33, and that comes up to be 147. So the supplement of that angle is 147 degrees. Okay, so pause for a moment and you try part B. Okay, so for the complement, you should have done 90 minus 95, and you would get -5. That is not possible. We can't have negative angles. So since this one, angle B is 95 degrees, it's already over 90, then it has none. It does not have a complement. So obtuse angles cannot have complements, and that's an obtuse angle. But it does have a supplement, so I can do 180 minus 95, and that gets me 85 degrees. So it does have a supplement, not a complement. And that happens for all obtuse angles. They don't have a complement, but they will have a supplement. Now, which angles won't have a complement or a supplement? Neither of them. Right, a straight angle does not have a complement or a supplement because it's 180 degrees, so it wouldn't have either, and a reflex angle doesn't have either of them. Okay? All right, example. All right, so notice we've got a straight angle, angle XYZ, and if I measured from here to here, that would be 180 degrees because that's what a straight angle is. So then by angle addition postulate, you know this angle plus this angle has to equal 180. So then these are supplementary angles, and they're also a linear pair because you've got your line with this and you've got your two angles. So then 2x plus 14 plus 4x minus 20 has to equal 180 degrees. All right, now you do your algebra. So 6x, oops, that should be minus. All right, that should be 6x minus 6 equals 180. Have to come over here. And then you've got 6x equals 186 because you add 6 over, and then when you divide, x is going to be 31. But you're not done because they wanted you to find the measures of the angles. So then we plug it back in. Measure of angle, let's see, I'll do XYW. That one is the 2x plus 14. So 2 times 31 plus 14. So measure of angle XYW is 76 degrees. So there's that answer. And then the measure of angle WYZ is 104. Okay, I'm gonna run out of time on this video, and so you'll have to watch the second video in order to get the other two examples.